Hi everybody, welcome back to the Enterprise App Patterns Reliable Web App Java series. I'm Matt Soka. And in this video, we're going to be talking about the security pillar of the Reliable Web App Pattern. So what am I talking about when I'm talking about security? Well, really, it comes down to three big things. And that's one, confidentiality. Making sure that your data stays confidential within your application. You don't want to have any data links. You don't want to end up on the front page of anything, right? You don't want to have any bad news happening about your application. You also want to make sure that your data has good integrity. And that means that you can trust that your data is correct, right? And that's part of security too. You don't want to have like, oh, I'm not sure that this data is good or not. You can be sure that it's good because you know that it hasn't been messed with at all. And then finally, if you know your data is secure and you have good security practices, you will be able to be available. Your app will be available as well because of the certain areas of your overall architecture can be cut off from the entire world, so to speak, except from your application. And so things that are very important to the application, maybe a database, let's say, will be available and won't have to suffer from any maybe DDoS attacks or things like that. So confidentiality, integrity, and availability all come into security. And when you move your app to the cloud, app services like Azure enable you to express these best practices more easily than before if you had to implement them yourself. So the cloud can implement and enable these advanced practices in an easier to accomplish format than what you could by yourself. And so 4 areas that we cover in the Reliable Web App Patterns are 1, managed identity. And so managed identity is actually a super, super cool thing that sometimes it takes a little bit to understand, but essentially it comes down to this. Imagine that your Azure service has an identity in Active Directory just like you or I would, right? So a lot of times we log into something in Azure Active Directory, username, and some kind of password, or let's say a multi-factor authentication. We have an instance, though, in Active Directory. Managed identity gives that to an Azure resource. We make that Azure resource a thing within Azure Active Directory. Now, let's not worry about any passwords because there aren't any in this case because it's already, we trust it because it is in Azure at this point, right? And so now this enables us, this managed identity enables us to have secure communication between Azure resources because we made it one resource and we made the other resources a thing within Azure, which brings us then to identity-based authentication. Because our Azure resources are now things within Active Directory, we can now say, you know what? Hey, app service, I'm only going to give you the ability to read certain things within Key Vault. I can do least role-based privileges and give them the least amount of access as possible based on their identity. So essentially now, because I made my identities, given my Azure resources identities, I can give them identity-based authentication. So those two go hand in hand. And then we also implement secret management within the Reliable Web App Pattern, and it's something that we recommend overall. And it's really storing Azure Key Vault, putting all your secrets there. And it's because Azure Key Vault's hardened and it's a great way to put your secrets. It's trusted, it has certifications, but really what kind of comes down to what's cool is that you can version your secrets and you can use identity-based authentication to get at your secrets and so on. And it's really easy for developers to use. In addition, easy for other Azure services like managed identity to get at. And then finally, endpoint security. And what this does is essentially you can harden off certain areas of your Azure resources to be inaccessible from the public internet. And if they can't be gotten at from the public internet, they can't be broken into, per se. So essentially, you're putting things behind a firewall and saying, you know what, only certain Azure resources, my Azure resources, can get to it, and then making them more secure that way. And so we cover each of these in a reliable web app pattern in our documentation, and I'll run through them here as well. So first, let's talk a little bit about managed identity and identity-based authentication. What's great about managed identity and identity-based authentication is that it's transparent to the developer a lot. So right now I'm opening up my app service, which hosts my web application. So I am going to open up the identity blade. Just search for identity. And once that spins up, I can see that I have a system assigned identity turned on, and it gives me an object or a principal ID here. Cool. And I can even go through and see what Azure role assignments have been granted to it already. And it says it has a Key Vault secrets user and a Key Vault reader assigned to it. So this is saying in this particular Key Vault, it's saying, you know what, I trust this particular app service to go out and be able to read from it. So, all right, that's cool. So let's actually go out and look at that Key Vault. So here it is, the Key Vault. And then in my access control, my IAM, I can go through and check access of what's been granted to it. So I'm going to go to Managed Identity, pick my subscription, and then pick my app service, and this is the app service. And I can see that it's been given Key Vault reader and secrets user, just as one would expect from looking at it before. So that's cool. What I've gone through and is I've given it particular access. And if I wanted to add it some more, I can go through and say, hey, add role assignment. Let's just say we wanted to give it Key Vault contributor as an example. We're going to really do this. We want to give it to a managed identity, select members, and I can go through and say, you know what, I'm going to say app service, pick it, and I can go select and then add it if I wanted to. And even better, I could go through in my Terraform infrastructure as code files and set this all up so it just runs and it's already ready to go for me after I do a provision. And that's actually how we've done the initial Key Vault secret user and Key Vault reader roles for this app service. We set them all up in Terraform. So that's cool. That's how you do managed identity. So the next demo I wanted to show, and I'll jump right into it, is Key Vault itself and how you manage secrets within it. Now this is going to be neat. I'm going to jump over into secrets. And when I click on it, it's going to tell me firewall is turned on and my client IP address is not authorized to access this Key Vault. So I'm going to go over to networking and see what's going on. And it says right now, allow public access from specific virtual networks and IP addresses. So right now it's saying, you know what, I have a VNet set up, but it's not, that's the only thing that could allow access to this Key Vault. So if I browse back to aka.ms, EAP, RWA Java, then scroll down to my topography and make this a little bit bigger. You can see my Key Vault is protected here by a private endpoint subnet. And that's what this is saying here. Only this subnet can get access to it. Cool. But not so cool when I'm trying to do a demo. So what I'm going to do is add my personal IP address to it so we can see. So first thing I need to do is say, what's my IP? And that's what it is. Back to here, add my IP address. Apply it. We should be good. And if we get lucky, I go to secrets, and now I can see them. Great. So I can see that I have an AirSonic database admin name. If I go into that, I'll see I have a current version. And if I go into here, finally, I'll see I have a secret value called very, very secret called my admin. Nobody would have ever guessed that, but this is just a demo. But with this, here's what's neat, is that to get at this and to use this, let's say I just leaked it to everybody. So what I would do is I would create a new version here, and I could enter a new value itself, and then set the old one to disabled. And then whenever I try to access this secret via the AirSonic database admin key, now only the new value comes through and the old value is now disabled. Cool, right? So that just works in quotation marks. It just works. All right, so that's really Azure Key Vault. My secrets are here and I can version them if I want to, and everything is great. Now, when I go back to my app service, who has, if you remember, permission to read Key Vault, I'm going to go look at the configuration. Now, once that pulls up, I have here, this right here is the secrets endpoint, my Key Vault secret property endpoint, which is just the URL to the Key Vault. All right, so that's sitting out in my configuration for app service. So why am I showing you this? I'm going to jump over to the code for the application. And so one thing that I'm doing overall is in my dependencies, I am declaring and bringing down a Spring Cloud starter for Key Vault itself. So I'm saying, you know what, application, it's cool. I want to be able to read some Key Vault out of here. And so by pulling that out and going here, Spring Vault, Key Vault, secret property sources 0 endpoint, I'm going to be able to go through then via this. This should look familiar, and pull out my secrets and put them in here. So AirSonic database admin. If I jump back to my dashboard, into here, into secrets, AirSonic database admin. This will pull out the database admin password. There that is. So I'm able to go through by setting up my dependencies. I'm able to grab things out and then pop them in and then use it. Easy, seamless to me as well. All right, and then finally, the very last demo I wanted to show you, that was our secret management, and the very last demo I wanted to show you kind of jumps over and talks about web application firewalls and how it is set to not let any traffic directly to our web app service, but instead making sure we have to go through front door instead. All right, so what we have set up then is an IP address restriction when we create the Azure App Service through the Terraform. And it's just an IP restriction rule, and it's saying, you know what, only allow traffic if it comes through front door. Everything else, we're going to block traffic from it. And the way that looks when we get over to the Azure portal is I'll open up the app service. We'll go look at networking. We can see the access restriction is turned on, and then I'll go down and see that it's denied unless it hits a matched rule, and that matched rule says it has to come from front door, which has a certain service tag allowed with it. Cool. And so then what I'll do then is try to get at this app service without going through front door. So directly from the Azure App Service within the portal, I'm going to click Browse. And I get a 403 forbidden. No dice. Can't get to it. But I go through and open up my front door from the app service just to grab the URL from it. Paste that in. and then I'm good to go. So because I routed it through front door, everything's good. And front door comes with things such as a web application firewall, which gives me protection from things like a DDoS. And so I hit the high impact, low cost of implementation win for me to come through. Great, and you can see all the code again at aka.ms/eap/rwa/java, and that page has links out to the documentation that walks you through why we did what we did with the reasoning behind it as well. So that was security, and ongoing, coming up next, we're going to talk about cost optimization, or some decisions and reasoning that you can go through to make your application cost just the right amount that you need it to for your situation.